When we compare the DBMS with file-based approach, we can find that there are so many advantages of DBMS. We know that in DBMS, the data are stored in only one location. So the advantage of this one is we don't have any data redundancy. Data redundancy means duplication of data. In DBMS, there is no duplication of data, whereas in file-based systems, there is duplication of data. And not only that, the data which we store in the DBMS is accurate. We can't have multiple copies of the same data. So in DBMS, these are the advantages, and not only that, many users can access the data at the same time, and we can also provide security to data in the DBMS, by using username and password. We can have security of data, and DBMS also supports multiple views, different types of users. They can have different types of views in DBMS. Like that, there are many advantages of DBMS, and to better understand the advantages, we generally compare these advantages with the disadvantages of file-based system.
The advantages of DBMS. DBMS has many advantages, and these are some of the advantages. First one is centralized data management. In DBMS, the entire data are stored in a single place. So many users can access the same data. So centralized data management, then data independence. Data are independent of the program. The programmer need not worry about the data, where the data is stored or how the data is actually stored. Data and program are independent in DBMS. Third one is data consistency. Consistency means the accuracy of data. So in DBMS, data is consistent because it is not stored in multiple sites. Whereas in file-based system, the data are stored in multiple sites. So there was a problem in file-based system. But in DBMS, the data are consistent. Minimized data redundancy. The data redundancy or the data duplication is minimized in DBMS. Then data integrity. Integrity means the correctness of data. In DBMS we have data integrity, and DBMS also supports multiple views. So multiple users can view the database in different ways. Then we will see one by one. Centralized data management. In DBMS, all the data are stored in one location. But have you observed in file-based system, data are stored at multiple sites. Different sites has, they have different types of data in file-based system. Whereas in DBMS, the entire data are stored in one location. So here it is the location where the data is actually stored. Then different types of applications, and application means the user program. A program 1 is accessing the data from the database. Program 2 or application 2, it is accessing the data from the database. And here application 3, it is also accessing the data from the database. And application 1 or the program 1 has a different type of users, user group 1, group 2, group 3, like that. So what we can understand by looking at this diagram, in DBMS the entire data are stored in one location. So this is the advantage of the first advantage of DBMS. Then the second one is data independence. Just now I told you the main aim of data independence is to keep data separated from the application program. Here there are we are talking about two things. One is the data and the second one is the program. What is data? What is program? Once again, data is the details of, for example, a student or employee or something like that, whereas program is written in a particular language, either C or C++, Java or some other program. Now this program or writing this program is different from or independent, actually what I should say is independent of storing the data. Then who writes the programs? Generally the programmers, they write the program. Then the data is actually stored in the database. Now the programmer need not worry about the data, how it is actually stored. But programmer is free of writing his or her own program. Now the DBMS provides an interface between the application programs and the data. These two are, we are talking about application program and the data. See, this is the application program which is generally written in C, C, C++ or Java or some other programming language, whereas this data are stored in the database. Now this DBMS, it provides, DBMS is actually a software which provides an interface between the application program and data. So these programmers, they are free of writing their own programs. I mean, the program, the Java program or C++ program doesn't depend on the actual storage of the data, the structure of the data. Now we have in DBMS two types of data independence. One is physical data independence and logical data independence. We'll be looking at these two terms maybe in the coming classes. There we'll see greater details of these two things, physical data independence and logical data independence. Let me tell you in a one or two lines the difference. Now if you see, the physical data independence means the application programmers need not worry about how the data are actually stored. So that's what we are talking about. Programmers need not worry about the how the data are actually stored, what data structure they are using, whether the data is stored in C drive or D drive or some other disk. The programmer need not worry about the actual storage of the data. This is what we call physical data independence. Physical data independence is the ability to modify the physical schema without causing the conceptual schema or application program to be rewritten. Here, we are talking about three different things. One is this one, the physical schema, which deals about the physical details, the inner details, or the details related to the disk. Second one is the conceptual schema, a little bit high level one. Then finally the application program. So these are the three different levels. This is the actually the first level, and the conceptual level is the second level, and the application program level is the third level actually. We'll be talking about these three things in the three level architecture. That's what I wrote here, three level architecture. Maybe we'll be discussing in the next class. There you can clearly understand the difference. Now there is something called logical data independence. The physical data independence deals with the first one and 2 3, and the logical data independence is the ability to modify the conceptual schema, this schema, without causing the application programs to be rewritten. Now, when we see these two statements, we can understand that there is something called independence. So, when we write an application program, we need not worry about the physical schema. Or, second one is when we change the conceptual schema, and these application programs, they are not modified. I mean, we need not modify the application program. Then the advantage of data independence. See, program data are independent in DBMS. The isolation between data and program is achieved. Yes, data, what we store, I mean, the student details or employee details like that. Program is the application program. Now, the modifications done at one level are not going to affect the other levels of the database schema. There are three different levels actually. When we modify the first level, it doesn't affect the third level. Or when we modify the second level, it doesn't affect the third level. That is what we call data program independence. Now the required time and cost to modify and alter the database are saved, because when we modify the first level, we need not modify the third level, right? So time is saved, and at the same time cost is also saved. Data consistency. What does it mean? Consistency actually means, accurate without any contradiction. Accurate data in DBMS, or by using DBMS we can get the accurate data. There is something called inconsistency. Let us try to understand what this, the word is inconsistency. Inconsistency means different copies of the same data will have different values. We'll look at one example in the next slide. In DBMS, the data are stored in single repository, and that is consistent data. Single repository, we store the data. Now here, in the file based approach, what happened, the in college office, we are storing the student name, class, address, and some other details. In computer science department, once again we are storing name, class, address, and some other details. For example, a particular student has shifted their home, then what happens? That particular student should change the address in the college office as well as in the computer science department, because two copies of the same data are stored in two different locations. If this particular student modifies the data in the college office and forgets to modify the data in computer science department, then what happens? Data are inconsistent. Data are inconsistent. Why? Because here one address and here unmodified address. So data are inconsistent in file based approach, whereas in DBMS approach the entire data are stored in a single location. So there will be only one copy of the address. When student changes their house, then what the student can do is the student can modify the data in the database. That's all. So the data is, or the data are consistent in DBMS, but not consistent or inconsistent in file based approach. Reduced data redundancy. What is data redundancy? Data redundancy means if, if the same data are stored at different sites or different places, it is called data redundancy, means duplication of data. Data redundancy in DBMS is reduced or eliminated because all data are stored at a centralized location. Once again, we see one more example. Here, in the file-based approach, the scholarship section, they maintain these details: name, class, section, Aadhaar, and fee in rupees, then date of payment, all these things. In the library, name, class, section, Aadhaar, book title, these things, these are the details they want to store in the library. Then have you observed these two files? We can observe that, the first four columns: name, class, section, Aadhaar. Here also name, class, section, Aadhaar. Then what happened? The data is duplicated, right? Or in other words, we can say that the data is, or data are redundant in file based approach, whereas in DBMS approach there is no problem of data redundancy, because The entire data are stored in one location, and at the same time only one copy of data we maintain here in the database management system. The next one is data integrity. What does it mean? Integrity means honesty, uprightness of data, or correctness of data. We can say that data integrity is actually maintained in the DBMS. Data integrity refers to the accuracy and completeness of data. Integrity is imposed through certain rules to the data in the database. So we impose certain rules, and we have referential integrities and some other integrities in DBMS. We will look at those things in the coming chapters. Data integrity is severely threatened when multiple users access the same data. There should be some mechanism where if the same data are accessed by multiple users, then at any time the DBMS should maintain the correct data. It should not give answer to one person in one way, and to some other person some other value. No, it should not do like that, right? So in DBMS, data integrity is maintained. Support for multiple views. We know that a database has many users. Many users, they access the same copy of the database. Users want to view a set of data according to their own interest. One particular person wants to see only a particular details of a student. For example, only student number and student name. Some other person may access only student name and section. Like that, different users, they may not look at the same information, but they look at different types of information. What is a view? A view is generally, it may be a subset of data, or it may be derived from multiple tables, which is also called as virtual data, because it is not actually stored. Virtual data is actually not stored. DBMS provides support for multiple views, so users can view the database according to their own requirements. Now let us see one more example to understand what this multiple view means. Now here we have a database where name, class, address, books due, how many books are how many books are due, then scholarship, how much amount the student is getting, then uh, fee due, how much fee the student has to pay. All these things are stored in a single table in a database. Now the first user wants to see only name, class, only books due. Maybe some librarian wants to see the name of the student, class, books due. Now this is view 1. He wants to see only the 3 columns among all these 6 columns. Second group of users, for example, scholarship section of an office, name, class, scholarships. They don't want to see the books due, right? So this is another view. And some other person, and this person wants to see only the class and fee due, right? This is another view. So DBMS supports multiple views, different types of users. They want to see or to get different types of information from the DBMS. In DBMS, it is possible. Now, finally, when we see all these things, centralizing the data, yes, it is implemented in DBMS. DBMS, the entire data are stored in one location. Data independence, yes, program data are independent here. Data inconsistency is avoided, and in DBMS we have data consistent data, and redundant data is reduced. Duplication of data is reduced in DBMS. Integrity is provided, then finally it supports multiple views. Not only these advantages, DBMS has many more advantages. Sharing of data, since the data are stored in single location, it can be shared by multiple users. Data security, yes, security and privacy, these issues are also addressed by DBMS. If a user has only username and password, that type of users can only access the data. Authentication and authorization, they are there in DBMS. And not only these things, but in DBMS we can back up the data. If one server is failed, or we can load the data from some other server. Like that, we can take the backup, and recovery mechanisms are also there in DBMS. So there are many advantages of DBMS. Okay, thank you.